Good morning. My name is Roby and I am from class 10 IPA B. So today I am going to explain to you Newton's law of motion. So let's get started. First, let's talk about history of Sir Isaac Newton. This is the picture of Sir Isaac Newton. So, Sir Isaac Newton, born in 1643 in Woolsthorpe, England. He is also an English scientist and mathematician. Isaac Newton is best known for his theory about the law of gravity. But his Principia Mathematica in 1686, with its 3 laws of motion, greatly influenced the Enlightenment in Europe. Today, these laws are known as Newton's laws of motion and describe the motion of all objects on the scale we experience in our everyday lives. So, what I will going to explain to you is the 3 laws of motion. So, the first law of motion, or that is known as the law of inertia, states that a body to remain at rest will remain at rest, and a body in motion will continue moving at a constant speed in a straight path unless an outside force will act on it. What does this mean? Basically, an object will keep doing what it was doing unless acted on by an unbalanced force. If the object was sitting still, it will remain stationary. If it was moving at a constant speed, constant velocity, it will keep moving. It takes force to change the motion of an object. Examples of first law of motion. The first one is a book lying on a table or a table lying in a room. They will not change their position until an external force acts on it. So this book will not change the position unless you take it or you move it to another place. So there is external force that acts on it. If you don't move it, the book will stay on the table and not move. The second one is when we roll a ball on the surface, it will come to rest due to friction and air resistance. If these forces do not oppose, the ball will continue to roll. So, in the example number 2, there is external force that stop the ball. This friction and air resistance stop the ball from rolling. If there is no friction and air resistance, the ball will roll and not stop. The third example is a man riding a bike. This man will keep moving if there is no external force, but here there is a brake that stops the man moving. Next, second law of motion. The second law of motion, or that is known as the law of acceleration. Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon 2 variables: the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object, and inversely upon the mass of the object. As the force acting upon an object is increased, the acceleration of the object will also increase. As the mass of an object is increased, the acceleration of the object will decrease. This is the formula of the law of the second law of motion, which sigma F is equal to m times a. So, what is unbalanced force? An unbalanced force causes something to accelerate. A force can cause motion only if it is met with an unbalanced force. Forces can be balanced or unbalanced, depends on the net force acting on the object. What is this net force? So, net force or F net is the sum total and direction of all forces acting on the object. Net forces always cause acceleration. This is the formula of second law of motion, and this is N or Newton, the unit of F, or N is equal to kilogram times meter per second squared. What does F equals to M times A mean? Force is directly proportional to mass and acceleration. Imagine a ball of a certain mass moving at a certain acceleration. This ball has a certain force. Now, imagine we make the ball twice as big. We double the mass, but keep the acceleration constant. F equals to M times A says that this new ball has twice the force of the old ball. Now, imagine the original ball moving at twice the original acceleration. F equals to M times A says that the ball will again have twice the force of the ball at the original acceleration. Example of second law of motion is, there's two trucks here. One is in a larger mass and hit in a smaller mass. The smaller mass will have large acceleration, and the large mass will small acceleration. So small mass will cause larger acceleration, and larger mass will cause small acceleration. Sample problem of second law of acceleration. Consider an elevator rises and speeding up with an acceleration of 2 meters per second squared. The mass of the elevator is 100 kg. What is the tension in the cable? The T is the cable, the mg is the weight of the elevator and everything inside. This one is the formula. So T minus m times g equals to m times a. This negative m times g we transfer to the right, becomes T equals to m times g plus m times a. T equals to the mass is 100 kg, so 100 times g, the gravity is 9.8 plus m, 100 kg times 2. The 2 is the acceleration. So 100 times 9.8 is 980 plus 100 times 2 is 200. So the T is 1180 Newton. Another sample problem is, what acceleration can a person produce when pushing a lawn mower? Suppose that the net external force exerted on a lawn mower is 51 Newton parallel to the ground. The mass of the mower is 24 kg. What is its acceleration? What we are finding is the acceleration. So this formula, the m, we transfer it to the left, become A equals to F net per m. The F here is 51 Newton, so we write it here, and the mass is 24 kg. This one is supposed to be 24. So 51 divided by 24 is 2.1 meter per second squared. So the acceleration is 2.1 meter per second squared. Another sample problem is a 1 kg object accelerated at a constant 5 meter per second squared. Estimate the net force needed to accelerate the object. This one is the formula. We substitute the mass 1 kg and the acceleration is 5 meter per second squared here. So 1 times 5 is 5 kg meter per second squared, and 5 the kilogram meter per second squared is the same as Newton, so the answer is 5 Newton. Next is mass of an object equals to 1 kilogram, net force sigma F equals to 2 Newton. Determine the magnitude and direction of the object's acceleration. Just like before, we are searching for the acceleration. So the m, we transfer it to the left, becomes a equals to sigma F per m. The sigma F is 2 and the mass is 1 kilogram. So 2 per 1 is 2 meter per second squared. And the direction of the acceleration is equals to the direction of the net force. Next, object mass equals to 2 kilogram. F1 is 5 Newton and F2 is 3 Newton. The magnitude and direction of this acceleration is, first we find the sigma F. The sigma F is F1 minus F2 equals to 5 minus 3. So the sigma F is 2 Newton. And the magnitude of the acceleration is sigma F per m. So the sigma F is 2 and the mass is 2 kilograms. So 2 per 2 is 1 meter per second squared. The direction of the acceleration is equal to the direction of the net force, which is direction of F1. And the last is third law of motion. For every action in nature, there is an equal and opposite reaction. If object A exerts a force on object B also exerts an equal and opposite force on object A. Here are the example of third law of motion. When you jump, your legs apply a force to the ground. So the action is the legs apply a force to the ground. So we give force to the ground, and the ground applies an equal and opposite reaction force that propels you into the air. So that is the reaction causing us jumping in the air. Other examples of third law of motion. Look at this man pushing the wall. What happens if you are standing against the wall pushing the wall? You can stand tilted because when you push the wall, you're giving force to the wall and the wall gives back the same force to you, causing you can stand tilted against the wall. Why does the boat go backwards while the girl jumps to the shore? Because when the girl jumps to the shore, this girl, she pushes the boat, giving it force, and the boat gives back the same force, pushing the girl forward to the shore, making this girl jump to the shore. Another example is many people are familiar with the fact that a rifle recoils when fired. This recoil is the result of action-reaction force pairs. A gunpowder explosion creates hot gases that expand outward, allowing the rifle to push forward the bullet on the bullet, and the bullet pushes backwards upon the rifle. And this is the last examples in real life is rocket. Maybe you've seen shows on television about rocket launches. Rocket motion is another example of applying Newton's third law of motion. The fuel is ignited in the combustion engine, producing hot gases, and the hot gas pushes in all directions inside the rocket and shoots out through the bottom of the rocket. The upward thrust of the gas launches over the rocket. As the gas moves down, the rocket moves in the opposite direction or goes up. So the action is the rocket pushes gas to the left, and the reaction is the gas pushes the rocket to the right. Sample problem of third law of motion. Tama has a mass of 40 kg. Then Tama pushes the wall with a force of 200 Newton. So the reaction force exerted by the wall on Tama is equal to, so this is Tama pushing the wall. F action is Tama pushing the wall. The F reaction is the wall exerted force to Tama. The F action is 200 Newton equals to negative F reaction. So 200 Newton is equals to negative 200 Newton. So F reaction is equals to negative 200 Newton. Another simple problem is this thing right here. 3Q Newton is equals to P Newton plus Q plus 2 Newton. The same thing here, P Newton is equals to 100 Newton. So the P is equals to 100 Newton. Just cancel the Newton. So P equals to 100. 3Q equals to P plus Q plus 2. Just cancel the Newton. So 3Q equals to P. The P is 100, so just put it inside here. 100 plus Q plus 2. This Q, transfer it to the left, becomes 2Q. 3Q minus Q is 2Q equals to 100 plus 2. 102. So 2Q is 102. What we're finding is Q, so divide all by 2. Q is 51. So that's the discussion for now about 3 laws of motion. Sorry if there's wrong word that I said before. Thank you and have a good day.